We just finished the psychology of learning, and now we're moving on to the psychology of thinking and intelligence, which is, of course, related. So, thinking deals with, I guess both of these deal with cognitive psychology, which includes things like perception, which you've already talked about, what we know, how we solve problems, the judgments that we make, learning a language, and how we remember stuff. So, cognitive psychology is just the psychology of thinking. I really don't know why we needed a new word, um, cognitive, in order to differentiate it from, I guess, other rudimentary forms of thought or what people kind of generally mean by thinking. But I guess it helps us make sure we know what we're talking about, and that we're on the same page, that we're talking about this from a psychological perspective. So whenever you hear the word cognition or cognitive, just think um, thinking or thought related. Okay, so think of cognitive psychology as the study of the little black box. So we can't see what's happening inside the head when thinking is occurring. We just know that information goes in and behaviors come out. And if I gave you information, you computed that and gave me some sort of answer, I'll know that something happened in between the information going in and the information coming out, and I can predict what that something was based on the transformation that happened. So, in this model, we've got information and sensation going in, and then we know that there are processes of thinking, emotions, memories, and then some behavior coming out. And so we can conduct experiments by manipulating what information goes in and then measuring what comes out and then testing our hypotheses about what's actually happening inside the mind during that period. So, part of cognitive psychology looks at the concepts that we use and the ways we solve problems. So, a concept is a category of linguistic information, it says here, images, ideas, or memories. And so, a concept can be used to see relationships among different elements of experience. If you teach a child that a dog has four legs and fur and a long snout, the child is going to develop a concept about what a dog is, and they might misunderstand and see a cow and say dog. Like, okay, well, that was the concept I gave you, but a dog lives inside, for example, or is much smaller than a cow, and so concepts can be adjusted and changed. And we can get good examples of dogs like my black lab back here, or like, I don't want to piss anybody off, but we can think of like examples of dogs that aren't really dogs or don't really fit that prototype very well. And so what we're talking about here is just how concepts represent. So these are words that belong to language that represent real natural things in the environment. And so we develop a language by coming up with words that correspond to things in our environment. Concepts are how we do that. So there are natural concepts, and actually, um, like watching waves crash on a shore, waves have a movement. And notice that the word waves begins with a W, and W looks like a wave, right? A wave that's been cut off. A snake looks like this, and that's what an S looks like. And so there are natural concepts and words that come directly from the things that they're describing. Onomatopoeia are words that sound like what they mean. And so, um, like a bubble popping makes a popping noise. And so these are natural concepts. And then artificial concepts might just be things that don't look or sound immediately like what we how we encounter them. Here we see like square and triangles, geometric shapes. We learn these concepts and learn what they look like, but really there's no correspondence between the word and how we encounter whatever the words stand for. Then we have schema and schemata or schemata. I'm not super familiar with these. I recognize all of the definitions, but schema isn't a word I use regularly. So here we see a schema is a mental construct consisting of a collection of related concepts. Um, I guess a good example would be like when you go into the student center or go into the cafeteria, or dining hall, I think is what my university wants to call it now, um, you might recognize the environment and people talking and laughing and have a sense of how to behave. And so you'll have a schema for the kind of informal dining area. And there'd be a different schema for being inside a lecture hall, especially a quiet one with a severe conservative professor standing at the front of it versus like a more interactive and energetic, smaller classroom with a lot of dynamic activity. Um, you would have schemas for each of these and expectations for what you would expect to have happen. Um, the pretty good example of what to do when you're in an elevator, and how we interact with people of our own culture. So if you've ever traveled outside of the country, you'll notice that the distance that you talk to someone from or the distance you take when you're having a conversation differs. Some countries prefer lots of distance, some like very short distance. I've found that when I was in India and the people that I interacted with always wanted to like stand very close to me and I kept wanting to push them away, but I didn't want to like make them feel unwanted. So I just felt uncomfortable about it. So there are certain event schema that are culturally bound, also socially bound. And so when we know already how to behave in an environment such as like a funeral, then that means that there's an event schema that's tied to that. Um, they give the example here of responding to a text message. And so if you get a text message or a phone call, it's like you have to respond to it, right? And there's like this strong compulsion to do it, even if the environment is inappropriate for it. You're driving, you're in a classroom, you're having a conversation with somebody, but it's like you almost can't pull yourself away from that event schema. Language is something that differentiates humans from every other species and animal and kingdom and so on. Um, Other animals communicate, but none of them have as sophisticated a language as we have. And part of that's why we have this giant brain, much bigger for the size of our bodies than any other animal. So language is made up of all of these concepts here. So we've got a lexicon, or think of like a dictionary. A lexicon is the set of words that we use. Grammar is the rules that govern how those words can be combined. A phoneme is the basic unit of a language, and so in English, um, we have sounds like e, I, all those parts, all those sounds that we can make, and by combining those in meaningful ways, we get like units of words, which might be um, any combination of the sounds that we can produce that make up a language, and that's called a morpheme. Now, the morphemes we have in English are going to be fundamentally different from the morphemes in like um, Hindi or Japanese. And so they have, if you've ever listened to a different language, especially a Slavic language, if you're used to like a Roman language or a Latin based language, you're going to hear things that don't compute. Like you're not even sure what sound they made because they don't belong to your morphemes. Semantics are the oh semantics are just the meanings of words, and so when you're talking about what a concept or what a word means or what an adjective adds to a word, you're just talking about semantics. And finally, syntax is the way that words and phrases are put together in a meaningful way. So that might involve commas and punctuation and long sentences versus short sentences. Significantly, language development is something that behaviorists could not explain. So, if we learned language the same way we learn how to tie our shoes, it would take us 1,000 years to develop the ability to speak in the past tense or in future tense. It just there's so many rules that need to be combined. So we actually develop it really quickly during this critical period when we're young. Um, and that's when our brain is developing. So as the brain develops, specifically the occipital cortex and parts of the temporal lobe, um, we rapidly develop our ability to interact with the world using language and understand the world using language. So it looks like, um, oh, this is a case study that's semi uh, related, I guess. So the case of Jeannie, the effects of language deprivation during the critical period can be seen in the case of Jeannie, who was 13 after being raised in neglectful and abusive conditions, grew up with virtually no social interaction, was unable to speak when found. They eventually developed a vocabulary but did not learn grammar. My guess is also, yeah, that'd be strange. If you never learned human grammar, um, you wouldn't be learning a second language, you'd be learning a first. So you wouldn't have the idea, even the concept of rules. So it sounds like there's a critical period in childhood. My guess is it's between the ages of like 2 and 6, where, and actually it starts as early as 6 months, recognizing morphemes that belong to the language of your parents or your family. Um, and if you miss that, you might never pick it up, which is pretty shocking. But we depend on it um, extremely. So here we've got a table of language development, so you can take a look at that to get a sense of at what age you pick up important or you develop important skills. There's a list here of problem-solving strategies that I'm not going to go through because they all look pretty basic. I'm trying to decide how to talk about spatial reasoning. Um, it's important to recognize, and this goes with intelligence, there isn't one clear type of intelligence. There are multiple types of intelligence. So in the US and most of the Western world, we privilege language intelligence, so reading and writing and speaking, and mathematical and logical, excuse me, intelligence, which is problem solving using abstract symbols such as geometry, trigonometry, algebra, if I said that. Um, but there's also spatial reasoning, the ability to orient objects in space and understand how things fit together and what relationships they might share. We don't really emphasize that a whole lot in the West, but there are definitely um, benefits for having that spatial reasoning intelligence, as well as like creativity, musical intelligence, movement intelligence, um, artistic and aesthetic intelligence, interpersonal, intrapersonal intelligence. There's probably going to be a whole list of those at some point during this slideshow. We, I guess, going back a couple of slides, the types of ways that we solve problems are ones that we rely on, and sometimes they're not always helpful. So we might get into the habit of always solving a problem the same way, but when we rely on this problem solving strategy out of habit, we might find that there are certain problems we can't solve, and we'll just assume that they're unsolvable because we don't have the tools immediately to solve them. But what we need to do is revise our problem solving strategy. So the best thing to do is be willing to let go of the strategies you've used in the past when they don't work anymore. Let them go, develop new ones. And so one of the problems is functional fixedness. So we believe we know that like coffee cups are only for holding coffee. And if we need something to drink water out of, we're like, well, I don't have anything. All I have is this coffee cup. It's like, well, yeah, you can drink water out of a coffee cup. It's like, no, you can't. It's a coffee cup. It's only for coffee. Um, that would be a pretty extreme example of functional fixedness. But it's difficult for me to give examples of functional fixedness because it's not something I struggle with. I like solving problems with tools that they're not made to solve. Um, so the ability to think creatively about your environment and what things can do and how to use concepts helps you avoid functional fixedness. These biases are pretty funny, but we all do them. These came from a study by Tversky and Kahneman in 1974, for which they won the Nobel Prize for economics because they showed how we do a poor job solving financial problems. Even though there's logic that we can use, we don't use logic. We use these faulty problem solving strategies. And so there's a whole list of them. I'll let you take a look at them more carefully. Now moving on to intelligence. I've mentioned it a few times already, but intelligence has to do with how skilled a person is in general. So it can be like physical intelligence, but we typically think about it as the ability to solve problems intellectually, to use our mind and how sophisticated our mind is. So a very unsophisticated example would be someone who struggles to understand language. So that example of Jeannie earlier would be someone with a profoundly low intelligence, at least from a language perspective. They might be fantastically good with their bodies. I don't know. Um, but there are ways of measuring intelligence and theories for what that intelligence is. So we've got Cattell's fluid and crystallized intelligence. Um, so crystallized intelligence here is fact-based knowledge. Fluid intelligence is being able to, I guess, do something. Yeah, knowing how to do something, um, recognizing kind of what's beyond the surface. So you might know that the sun rises in the east and sets in the west. So that's like book knowledge. You know that you can repeat that. But to really understand what's going on um, from an astronomy perspective or astronomical perspective, from some place outside of the universe, to see the relationship between planets and the sun and their movements and being able to put all of that together would be more of a fluid intelligence. So it's a much deeper understanding. I suspect, so be able to see complex relationships, but also knowing how to do something. So I might know how to build a brick wall, but to actually have the skill to mix the mortar and lay it and set the bricks just so, and have it look good and uniform would be a fluid intelligence skill. And then Sternberg has the triarchic theory of intelligence. So there's three different parts that are interrelated. These are the um, practical, creative, and analytical intelligences. Practical intelligence is common sense, being able to understand the social environment and interact within it. Creative intelligence is being able to solve problems without following predictive rules. And analytical intelligence means taking rules and applying them to um, predictable cases, in order to solve those problems. And that you can see that these are all interrelated, that they build on and benefit from one another. I mentioned these multiple intelligences earlier. Howard Gardner, I believe he's still alive at Harvard. He believes and argued and measured that there are at least 7 initially different intelligences, and he later added an 8th. I think he's actually since added a 9th, which he calls existential intelligence. I had a colleague share some information about that with me. Uh, I mentioned that we tend to emphasize logical, mathematical, and linguistic. So if you're like a 4.0 student, you're probably good at those. And if you are a musical and, uh, let's say, kinesthetic learner, you probably aren't doing quite as well in school because we don't emphasize those quite as much. Gardner wished that we could design curricula around your intelligence so that you could do what you're best at and get even better at it. That school should support the intelligence that you have, not the ones that society believes you ought to have. Creativity, I think, is gaining recognition and appreciation in higher education and possibly K through 12. It just has to do with being able to solve something without using or think about a problem in a new way. So this is creative problem solving. Some of the features of creativity: um, having intense knowledge, working on a skill for a number of years, looking at novel solutions. That was what I said earlier, the example that I gave. Seeking out the advice and help of experts, taking risks. Yeah, creativity has to do with being willing to put yourself out there, to try something new, take risks, learn from mistakes. All of those things are ways of developing your creativity. Um, Two concepts: divergent and convergent thinking. Convergent thinking means all all answers are pointing towards the same conclusion, or all paths lead to the same place. Everyone is thinking about it the same way. Everyone is in agreement. Divergent thinking is the opposite. It's like, well, we could try that, or we can try that, or we can try that, we can try that. And so divergent thinking tends to be more creative. Convergent thinking tends to be more predictable. And you can't say one is better than the other because it's context dependent. If convergent thinking is working, it's fine. If it's not working, you need divergent thinking. And sometimes all the divergent thinking in the world won't solve a problem that we already know how to solve. So intelligence can be measured any of these ways. You can take an intelligence test about multiple intelligences, but the way that we typically measure intelligence has to do with the Binet-Simon or Stanford-Binet intelligence test, which looks at a bunch of different facets of intelligence and compares your score to the average for other people your age. And so you get an intelligence score. A score, a normal score would be a score of 100. 100 is like average. It's not high or low, it's just what most people have. Um, and if most people had a higher intelligence, then the 100 would just move up to wherever people's intelligence are. If you're 90, you're below average, but not a lot. If you're 80, you're starting to get like a significant distance away, like a standard deviation away. Or if you have an intelligence of 110, it's still pretty much average. 120, okay, now you're above average. 140, I think, is like the genius. 73, I think, is the cutoff for an intellectual disability, something around there. Maybe the slide will show it. There's Binet. He was the one who designed the first intelligence test and tried to um, standardize different intelligences for different ages. Then we have the Wechsler's intelligence scale. So there's a adult and child one. Um, there's something called the Flynn effect, which I don't know. Oh, it said that each generation has a significantly higher IQ than the last. My guess is that's because whatever qualifies as high intelligence is then taught to subsequent generations, and therefore you would see higher IQs. Another explanation would be that people are just getting smarter, evolution at work. When we're talking about normal intelligence, when I said intelligence of 100, that just means on this normal bell curve, which represents the whole population, so everyone falls in this distribution. Some are higher than on average, some are lower than average, but most people are average. That's why it's called average. This specific graph shows the height of US women, and I've seen this exact graph before that I used for a different class. Anyway, the average height of a woman, according to this graph, looks like 5 feet 5 inches, and 5'7" down to 5'3" is one standard deviation above and below. So that means 68% of women are between 5'3" and 5'7". So if you are a woman and you're in that bracket, you're average height. If you are above 5'7", then you are significantly above average. You are one standard deviation or more above average. And if you're 5'3" or below, you are one standard deviation below. All that means is you belong to a minority of women who are above or below average. So we can map intelligence that same way. We can map pretty much anything using a bell curve. So here's an IQ bell curve with 100 in the middle. Looks like they say in between 85 and 115 has 82% of the population. And 85 is one standard deviation below the mean. So it doesn't say what intellectual disability is. You can look that up if you're interested. But there is a number that is officially intellectually disabled. So is intelligence something that you learn, or are you born with it? That's the nature or nurture question. If you're born with it, then it's in your nature. You're born with a high or low intelligence or average intelligence. But if you learn it, then based on the experiences you have growing up, maybe you're in an intellectually rich environment with lots of learning opportunities, that intelligence can be learned. So most psychologists now believe levels of intelligence are a combination of both. And of course, how could you really tease those ones out? Genetics and IQ. The correlations of IQs of unrelated versus related persons reared apart or together suggests a genetic component to intelligence. It's very difficult to test nature versus nurture. You really have to do twin studies. So these are two identical twins that are somehow separated at birth and have two very different environments growing up, and then measure their intelligence and if see how different they are. So it looks like when identical twins are raised apart, they don't have the same intelligence, but it's about 74% the same, which suggests that it's a pretty strong genetic component, whereas adoptive parents have about a 20%. The IQ of an adopted parent has a 20% likelihood of predicting the IQ of their children. So that suggests there's a pretty strong genetic component, but it's not entirely um, genetic because it's not perfect. You don't see 100% in the um, identical twins. There are learning disabilities, and these again may be genetic. They could be partially environmentally based. Dysgraphia is the inability to write legibly. I may have that. Dyslexia is the inability to organize letters in a predictable way. So they're kind of jumble, like you see in this picture here, teapot. Um, there's also dyscalculia, the inability to do math functions or struggle doing math functions. Um, I don't know what that tiny text is about. Uh, there are therapists that you can see to help with learning disabilities, and I think there's still kind of there's no consensus on the best way to treat these, or if they are curable, or if it's just something that a person has to adapt to and live with. And so, of course, when we normalize learning and say that there's something that learning looks like and something that it doesn't look like, and we normalize intelligence and say here's what intelligence looks like and unintelligence looks like, we're going to have disabilities there. So if someone doesn't fall into the normal range and they're below it, then perhaps there's something wrong with them, or if they're above it, then there's something great about them. Once we have a standardization process, there's going to be outliers, and those outliers get pathologized, which is why we have learning disabilities. That is it for learning and intelligence.